Hi, I'm Vijay Gill. This is John Mitchell. John actually did most of the work here. I'm just speaking on it. We work for AOL, specifically in the ATDN division, which is the backbone portion of the AOL business. So this is not something that we have strong religious opinions about. We considered OSPF. We were running OSPF fine. We looked at ISIS, and for us, ISIS just happened to give us more benefit than OSPF. For other people, the equation may be different. So this is a nice little quote which basically sums up our philosophy on IGPs. So why did we do that? Why did we feel that ATDN would be better served by moving to ISIS than OSPF? Simple, because we were looking for features. ISIS is a fairly small knit community. There are like a handful of large ISPs that run ISIS. Mostly everybody else does not care, unlike OSPF. So things that we wanted done in the protocol, we could get a faster turnaround through the IETF, through the vendors, because, well, there are basically about 20 people who really care, and we know all of them. To be specific, the feature that drove us fastest to ISIS was fast convergence. Cisco, our primary vendor, is putting in the fast reconvergence code in ISIS first. There are some security implications and as well as simplicity, because we went from a multi-area OSPF to a single area ISIS. So here's a good quote. Some people tend to think that ISIS is actually complicated. So that's Chance Bailey, ex of Quest, I believe. He's completely incorrect. Now there's a large amount of discussion on OSPF. This is Mr. Katz's slide he gave at NANOG. This is a URL. The primary reason we were concerned about for security was packet bombs in OSPF, which really wasn't as big of a concern for AOL as it is for many other people, because we have filtering turned on in almost every edge-facing line card. Unfortunately, not all of them, but the big ones are all packet filtered. ISIS runs directly on L2 and therefore is much harder to spoof or attack from a distance. Simplicity. This was, I believe, one of the key drivers that motivated our management to push for ISIS. We had OSPF in a multi-area configuration in our POPs. It added complexity, it added extra configuration, it added typos, because we are not where we are generating our router configs by automation yet. We are still doing some of it by hand, and people tend to screw up network statements, masks, and tend to cause minor issues. OSPF also is distance vector between areas. It's link state within an area, but if you go from area X to backbone to area Y, you run a distance vector calculation. Is that a real problem? No, but the Cisco guys felt that it would add extra complexity that we didn't really need. The benefit was not worth the extra amount of work. And also, flat areas are easy to maintain, because we are not the smartest people around, so what is simple is good. So this is what our OSPF area looked like. And I actually apologize for actually having config bits instead of red router, blue router, but this is. So this is the backbone. Over the top, we have area 0. This is the POP. All the edge routers are here. They are in the area X, wherever the BGP cluster ID of the POP is. Again, fairly simple. No rocket science here. So here's our strategy. The basic strategy was that when you're changing the tires on a moving car, make sure that one wheel is on the ground at all times. So we ran the network in parallel, installed ISIS, verified the routes, changed the OSPF distance to be higher than ISIS, verified the network, and then removed ISIS. Oh, I'm sorry, OSPF. Oops. That would have been bad. So here's what our network looked like. The red star is approximately where we were doing the change from. So this is Japan over here, California, Europe, the US. All of it is OC192 except portions of Japan. This is a fairly large network. And we also, very important, to verify out-of-band connectivity. because when you're doing changes in band and you destroy your transport infrastructure, you cannot rely on in band to get you out. So the first thing we did was verify that we had true out-of-band connectivity to all our POPs before making the change. I suggest you do the same. So here's basically a prep. We qualified an iOS, loaded it onto a test POP. This is actually, RTL is actually a POP, which is a live network POP, has all the configurations, but there are no customers on it, so we can deploy incremental changes in that POP, verify that it does what it's supposed to do, and then if it goes wrong, it doesn't destroy the rest of the backbone or affect customers. We developed scripts against this POP so that we could verify that what we were trying to do was actually correct. Oops, what happened here? Here we go. Okay, so the entire migration took 2 days. Monday and Wednesday were the effective days of change in the network. So we loaded the configuration pre-generated by script that John wrote, which took our OSPF configs from rancid repositories, ran a script over them, and spat out the ISIS configs, one per router, which we loaded up. We changed the OSPF admin distance to 254 on some edge routers to verify that the routing actually would work. RTL was one of them. Then we compared ISIS and OSPF routes on each pair of routers to make sure that what was visible in ISIS and was reachable via ISIS was also congruent to what was visible and reachable via OSPF. Then last minute check, verify that the ISIS and OSPF costs were the same, because there was a delta between when we generated the configs and from when we actually executed the change admin distance command. So we wanted to make sure that right before we did it, that the OSPF metric topology was congruent, not the same, but congruent to the OSPF metric topology at that time. And then, of course, there were some basic reachability tests, ping the routers, and rely on the NOC to monitor external sites to make sure that we had everything working according to plan. And of course, there was no verification done post-migration, because if you want to verify something after the horse is out of the barn, you've already lost. We ran a bunch of scripts to remove the OSPF configuration. That was the week after, and we were done. So this is what our ISIS network looks like now. So you have the POP routers. If you remember from the OSPF slide, the backbone area went something through like that, half through the routers. Now they have just been pushed all flat. ISIS runs all the way down to the edge routers. No major change here. You will notice if you look back at the slides on the web, that the metric cost here is higher than the metric cost there in OSPF. And there's a reason for that, which we will go into later. Any questions so far? I am going deliberately fast because, well, this is kind of boring. I mean, I could put in red routers, blue routers, but I might get shot. So here are the config bits, the essential config bits for our ISIS configuration. We went ISIS level 2 because if at ever some point we wanted to migrate to multi-area ISIS, if we ever grew that large, we could easily incrementally add level 1, as opposed to having the entire backbone as level 1 and then trying to retrofit multi-level ISIS. Metric style wide standard, so we could have congruent metric space with OSPF. The key part here is external overload signaling. ISIS, some routers, some vendors' routers will not drop an ISIS adjacency if DSEF stops forwarding on the line card, which means that your router the interface and the line card will stay active in the ISIS topology and will be placed on the shortest path, even though it no longer forwards IP packets. This command will tear down the link in case DSEF fails on that particular line card or port. And of course, the standard wait for BGP, because the ISIS converges in order of seconds, BGP converges on the order of minutes, and you don't want to place a router on the shortest path before it has all the routes, otherwise you will black hole traffic until such a time you are finished with the BGP conversions. Of course, no hello padding. This was used when there was actually a chance of MTU mismatches. That is no longer the case. Our vendors have deprecated this command. So here's a little bit of our design for this. We went with the standard IBGP hack. Earlier, we were relying on OSPF and specific allocations per POP to carry the reachability into the POP. We no longer care for that. We have removed that. All edge interfaces are put into BGP. ISIS will still be preferred for those prefixes or links that are in ISIS because ISIS has a lower cost. And redistribution into BGP was so that we could reduce our SPF. Now, is this really a problem? For our network, very large, very flat, very fat pipes. It's not a whole mesh. No, it's not really a problem, but it was a zero cost optimization. Didn't hurt us, so we did it. So here's some of our costing design. As you saw before, these links, I love this laser pointer, by the way. Thanks, Avi. These links are on very high cost, 500, 500. Backbone costs are in the order of 10, 1, 20. The reason we did that was if this link fails, we do not want traffic inversion, that if the backbone router to backbone router link goes down, we do not want traffic to go through the POP router, back out to the backbone router, and through the network. So we added 500 to the OSPF metric, which was like 1, 2, or 4, which is the standard intra-POP metric, so that we could never have traffic inversion. This is at least an order of magnitude higher than any other cost in the backbone. Of course, the problem with that is that it leads directly to the med oscillation issue. And so the way we mitigated the med oscillation issue, and there are several presentations from Cisco, there's a draft out on this, or RFC now, is that we turned on full mesh within the client, within the POP, and made sure that the cost of the intra-POP links, the backbone links, was greater than the cost differences within the POP. Okay? So if the cost differences within the POP are on the order of 2 or 4, make sure that the lowest backbone cost is on the order of 10. Make sure, otherwise you will have BGP med oscillation issues. And of course, that changed our cost of procedure to add 10,000 to the interface, so there's no way anybody's going to use that. So here's the actual timeline. About 2 hours, load the ISIS config. This is about 6 a.m. onwards. Verify the routes. This is on Monday we started, we loaded the ISIS configuration. Tuesday, make sure all the routes are in ISIS the same as they are in OSPF. Switch the distance at 3 in the morning. Confirm that all the reach works. This time is total about 4 hours. And a week later, Monday, remove all OSPF from the backbone. The change, loading ISIS config, was completely non-disruptive. Nothing happened, which was a pleasant surprise. It has not been the case always. We had a script that took our OSPF config at that moment from the last rancid run, dumped it into ISIS, and then was copied to each router. At that point, no ISIS routes were in use. So we wrote a bunch of scripts that compared the ISIS topology with our OSPF topology, make sure that the topologies were congruent, that we were not routing to Timbuktu when we really should be routing to Tokyo. Check the ISIS database, that the ISIS topology, the actual database, was congruent with the OSPF database. We took both databases out and compared them. John again wrote those scripts, very tough. Then on selected edge routers, we pushed the OSPF cost up to 254 so that the OSPF routes for that network, for that particular router, were no longer in use. So now at this point, we have the network in a half and half state. To get to some networks, you're following the OSPF topology. And to get to some peers and other parts of the network, we are following the OSPF topology. So good thing that we had verified that they were congruent, because this is where, if there is trouble, this is where you'll start to see it as you start to have loops, because your OSPF tree is pointing in one way and your ISIS tree is pointing the other way. Again, compared, then we made the go, no-go decision to move forward with this. One other thing that was unexpected and that we actually knew about, but we didn't actually think that we were going to hit it, was that changing the metric affects the med. Now, due to our change in the intra-pop links, our ISIS metrics were higher than the equivalent OSPF metrics. Now, the topologies were congruent, but the costs were different. This is very important because 1 minute after the new IGP change, the cost has been propagated into the network, the BGP will change its med. Unfortunately, this is, again, vendor implementation. The BGP, the metric change will not propagate for 10 minutes. And we had a large peer that was listening to our meds. Unfortunately, we did not also have enough capacity to that peer that we could change the cost on one router, and then as everything went away from that router because the OSPF cost, ISIS cost was higher, we did not have enough capacity on the other circuit to take the entire load. So those large peers were special cased. We loaded them manually and then migrated the entire set of those routers at the same time. We manually cleared the IP-BGP soft out to ensure that, the metric changes for that particular peer took place roughly within a couple of seconds worth of window, so that we didn't have a huge traffic slosh. And I'm talking on the order of like multiple gigs. So the big one, Wednesday morning. We verified that the current network metrics were consistent with the config files, the OSPF metrics. Manually changed the admin distance on a few routers, so we sort of slow started it, verified that it was a go, no go, and then ran a script to change the entire network. Now, looking back to the star I was pointing about, we ran the OSPF conversion in order of distance from where we were actually attaching to the network, so that in case we actually screwed up something bad, we could still go to the point closest to that screw up, manually go link by link, and then fix the problem. We had out of band, but we preferred not to use it if possible because out of band is slow. Once we verified that, we ran everything in those order. So Europe, Asia, Brazil, the US edge routers, and then the US core routers. And then the last one was the data center DC area where we were actually sitting, so that if anything had started going wrong at the edges, we would know about it by now. So all the routers, all the routes that were external routes in OSPF are now carried in IBGP. Whoa, that's a lot of talk. Any questions so far? Anybody still awake? Okay. I have the laser pointer, Avi. Susan has a question.
During the migration, did you run into any undocumented or unfound bugs within iOS regarding ISIS?
Strangely enough, we were actually just going to talk about that right now in this slide. There were some ISIS fixes that were put into the code that was qualified for deployment. They were actually, knock on wood, nothing happened. There were no bugs. It just worked. I mean, you could have like picked our jaws up off the floor.
Which version?
Huh?
Which version of iOS?
21 S7? It was S7 or 6 at the time. Basically, N+1, whatever N is at any given day. So the act, I'm sure. I'll repeat the question.
My question is,
Right.
you said the timeline was 1 week from the time you started to finished
Right.
on just the cutover. But how much pre-planning did you have to do to write the scripts? I mean, was that like 6 months, 2 days, kind of the scope of the project itself?
John would be better able to answer that.
Yeah, so there was kind of a number of other issues that I think you all recall with security-related issues with certain vendors' code. So a lot of things stopped the rollout from occurring when we first designed it. So in actuality, we decided to move to ISIS roughly 9 months or a year before we actually did the rollout. Now, obviously, we didn't spend all that much time working on those things, but I'd say that man hours in scripting and preparation were along the lines of maybe 2 weeks on the scripting and stuff side, and then on the iOS, like coming up with the config and stuff. I mean, that was yeah, maybe about a month because of the testing that was involved for ISIS to make sure that everything was going to work okay.
Okay, thanks. Oops, we have another question. Vijay.
Okay.
Hey, Vijay.
Hey, Chris.
When you were trying to solve the transitivity problem through the edge routers, did you consider setting the overload bit permanently on those routers?
No,
because you were putting the loop back only and you weren't redistributing connecteds anymore?
No, we did not set that because we actually wanted, we were fairly confident that the networks, the topologies were actually congruent. So they would do the right thing from routing perspective, which no matter which database you pick to route with. We deliberately did not put up no overload because we wanted to verify connectivity through those routers.
Right, so using BG or non-BGP routes then?
Yes.
Oh, okay.
So,
Because I was
yeah.
just thinking, we were thinking of doing that ourselves, and I wanted to see if you know, rather than going through the med oscillation problem in that you changed the IGP metrics and then, of course, the meds changed.
Right.
If you considered using that method so you can maintain metric congruence, you know, between OSPF and ISIS and not have to deal with that.
Yeah, we decided this wasn't worth the effort. And I'll show you in the slides, we actually did it while passing live traffic. And so there was actually no disruption whatsoever.
Cool, thanks.
So the convergence time for installation in the forwarding table, so that 10 minutes, was under a second. And the reason for that was that there were no Ceph updates to the forwarding table. Now this is a non-intuitive result, and we were kind of surprised by it ourselves, but we verified it repeatedly in the lab. The costs changed, but the topology did not. This is the key part. So the costs to reach certain things have changed, but the paths you would take, the shortest path tree was still in the same shape. So the forwarding table did not need to be updated when we switched from OSPF, routing on OSPF to routing in ISIS. This is very important because the entire section for the new routes was under a second. We use under a second because our lowest resolution we could get was a second, so it could be like on the order of like 100 milliseconds, we would not know. And of course, very important thing, last but not the least, rollback in case we did make an error. We had pre-written scripts that would immediately roll back the network in reverse order from where we started. So in this case, we would start rolling back from where we were to the edge, as opposed to rolling back in from the edge to out. Whoa, please, Bill. And after it was all burnt in, 1 week later, John ran a script, removed all OSPF. The old configs are archived in Rancid. We are done. So this is actually the mail that was sent out after the maintenance was done. Here's our user graphs. And this is the line of truth. This is when the actual maintenance was happening. And as you can see, there's no user drop whatsoever. And our client is extremely susceptible to, extremely is perhaps an understated word, is very susceptible to routing changes. It drops users left and right if you change things much. Here's an actual traffic graph. This is speaking to Chris Martin's point. This is in gigabits per second here, blah, blah, time. This is the config window when we actually switched the OSPF to ISIS. As you can see, there's almost no traffic change. It just continued on the graph. The reason we picked this time to change as opposed to the absolute peak time is the traffic graph vector. The vector is going down. So it's always easier to knock people off when they're going to log off anyway, as opposed to doing the same thing here when they're trying to log on in case there are mistakes. Because when they're trying to log on and they can't log on, they get very irate and our call to member services goes up. However, if they're going to go to bed anyway and it knocks them off, they're like, oh, screw it, damn AOL, and go to bed. So the direction of traffic, I mean, you will notice that we did the same thing for the user graph. I mean, of course, our user graph tends to follow sun. We changed things on the downward direction so that there's an actual vector to the component of traffic change, as opposed to changing it at the very bottom. So this is something we did at our last job, at my last job at MFN when we did the change. We had this big board up, and we were converting from OSPF to ISIS at the same time. I think Leo and Rachel were there at the time. This is very important when you're doing things like that have high visibility to management. Because knocking like a couple of million users offline tends to get you noticed, and not in a good way. So any questions? And of course, when I mentioned to Brooke at Global Crossing that we were switching to ISIS, the first question out of his mouth were, are you thinking of smoking off the MPLS hookah? And then when I mentioned to my mentor, Bill Barnes, ex of UUNet, that we are going to go to OSPF for ISIS for simplicity, he came up with this quote: "There's a difference between making something foolproof and reducing the number of fools." I still don't understand it. I think he was meaning me. But any questions?
I got a couple questions. Danny McPherson. Just wondering, you guys do a pretty good job at your post-mortem stuff, going back and keeping track of tickets and whatnot. Have you seen any realized benefit of transitioning?
Have you seen any real-life benefit?
In number of like IGP-related bugs going down in your network?
John? Yeah.
Actually, before the change, only in a code version almost 2 years ago did we ever see any IGP-related bug. I don't think the IGP is something that we normally have problems with, so no in that respect. But for our auditing of the configuration, because of the simplicity, we definitely realized real gains in moving to ISIS.
Okay, good. What about operational learning curve for like the NOC folks? I mean, you know, I've got a pretty good handle. I know you guys do on different IGPs, but was there a huge learning curve there? Did you do a lot of training or whatnot beforehand? Or?
Actually, no. I mean, we've done this at like at least 2 other networks before. And once people get over the fact that they're seeing a net instead of an IP address, it's extremely simple. I mean, there isn't much to ISIS debugging because there's only like 5 commands you can run.
Right. No,
So you just run the 5 commands and you figure it out. So,
and my last question was,
Oh, sorry, let me follow up on that a little bit. The NOC didn't have any problems, but there was actually pretty extensive training. And I'd like to thank also Cisco for providing a lot of that. So.
cool. And have you seen tangible benefits from actually doing the transition?
from doing the transition, yes, we have a bunch of very experienced engineers now who know how to do large-scale jugglings of this kind of things. One, any material benefit, not yet, but as soon as the new code gets qualified and we upgrade all our GRPs, we will be seeing new benefits.
Yeah, that's good. That answers part of it. So I was wondering more like, SPF runtime takes, half as long, that kind of thing.
Well, yes, there is. But again, the difference between going from a 500 millisecond SPF run to a 400 millisecond SPF run is not yet imminent, is not yet visible.
How you doing? Tony Armadas, ABN. My one question was, since the entire network is completely flat, is there any concern with the actual link state database and having a corruption start from one side to the other?
We actually have worked with this. When I was at UUNet, we were running a flat data network that was about 10 times larger in terms of number of links and routers. Also, we talked with Cisco developers and Juniper developers and Procket developers, and none of them indicated that areas were necessary in terms of reducing consumption of resources in the routers.
I guess, yeah, more of my concern, would be like with OSPF, you can obviously run multiple processes and edge them off and do a little bit more redistribution filtering between, instead of using typical areas, like using area, more than area 1, 2, 3, 4, right. Using multiple processes and then redistributing between them to kind of control the link state database and edge that type of service off. Yes,
I know several networks who have done those kind of things, and I'm not the smartest person in the world, but I'm smart enough to realize that anytime you try to do multiple redistributions and controlling of link states and stuff, your design is fundamentally flawed somewhere, because you can do it, but the NOC has to maintain it and the NOC has to debug it. And I mean, I'll be honest here, like looking at a three-state OSPF router, it's like, who the hell knows what the hell's going on? I certainly don't. And I don't want our NOC to sit there at 3 in the morning trying to figure out why a particular prefix is not reachable. So in general, what is simpler tends to be better.
Last question.
Hey, BJ. I think you pointed out a subtle point that, I don't know if, is Craig here, Leibowitz? Because of your rich connectivity to other providers, I'm assuming that there was a lot of med churn because as you were changing the metrics on each link and kind of going through, then you would have been doing a lot of updates. Right. And based on, the way you're peering, most of them would have been ignored because it's mostly peers. I wonder if, I don't know if this is something that could be done now, but I wonder at least if you considered the way you were connected before you decided to do the metric adjustment, because if you were buying a lot of transit and your providers were listening to your meds, then you probably would have been subject to, I would probably suspect, a lot of damping. So I don't know if anybody else noticed that, but is there any like BGP measurement still being done today where somebody could maybe dig into some archives and look at 1668 and say, wow, we didn't really see anything? Because this is about as big as you can get in terms of, you probably sent out like many thousands of updates, to at least to your peers over the course of the migration, and it didn't appear to affect your traffic in any negative way.
Well, actually, we're lucky enough to have aggregated pretty well. So, I mean, we're not talking about a huge number of routes overall. But on the other side, I think the traffic patterns show that it's unlikely that much was dampened. Otherwise, we would have seen a significant traffic drop-off. We have done some studying into the effects of BGP dampening that other providers are using, especially using some of the Route Views project's data. And what we have noticed is that 2 updates usually do not cause dampening, and that's all we were actually doing at this point.
Okay, so you were announcing your aggregates from a point close to the boundary of your network, and like injecting them from there. They weren't like being aggregated in the core somewhere where you would have lots of metric churn.
I'm not saying that. All route announcements did get new meds sent out on them. Whether or not, as you pointed out, not everyone was listening. The other thing that comes into play here is that, I mean, we're only talking about 1 or 2 updates that went out to peers. There weren't numerous, like you had said, numerous updates. There wasn't numerous updates of the route announcements. Okay. So, I mean, it was really just one flipping of the switch that caused, on the edge router specifically, when the admin distance changes, that was when the med went out to the peers. For the most part, when you're saying, I think that you're correct that if you aren't careful about this, and if you are buying a lot of transit, then I guess that would be a problem for you if most people were listening to your meds. In our case, we knew exactly which networks we needed to deal with, and we took care of those, as we said, ahead of time, so that the announcements went out at roughly the same time.
Cool. Thanks, guys.
Okay, that's it. Thank you.